This is question 50 on chemistry from the 2018 NSAA. So we're told that some dilute hydrochloric acid and some magnesium were mixed and that the total volume of gas released was measured over time. And that's what's displayed in this graph, with the volume of gas in centimetres cubed against the time in seconds. We're then asked, what is the average reaction rate with respect to the magnesium over the first 2 seconds in grams per second? And we're given some information, that's the relative atomic mass of magnesium and the volume of 1 mole of gas. So where to begin? Why don't we start by writing an equation for the reaction that's happening? Can you figure out what it is? So we have magnesium and hydrochloric acid, and magnesium naturally wants to lose 2 electrons and form magnesium 2+ to form magnesium chloride, with the chloride from the HCl, and the hydrogen will then form neutral hydrogen in the gaseous form, H2. And what about the reaction rate that we're being asked for? Well, this is the average reaction rate, which makes it quite easy, because we don't need to worry about the curve of the graph. We can just read off that 24 centimetres cubed of gas was released in 2 seconds, and we just need the average rate during this bit of the graph. So how can we go about finding this? Well, what is the gas, firstly? The only one from the equation is this hydrogen that's produced. So we can read off that 24 centimetres cubed of hydrogen is released over 2 seconds. So what's the rate of reaction? Firstly, with respect to hydrogen. Well, if it's 24 centimetres cubed in 2 seconds, then the rate in centimetres cubed per second will be 12. But we don't need the rate with respect to hydrogen, we need it with respect to magnesium. So how can we go about changing this? Well, we're told that 1 mole of gas is 24 decimeters cubed, so maybe if we convert from centimeters cubed per moles, we can find it out for magnesium that way. So what do we need to do first? If we change the units of this rate from centimeters cubed per decimeters cubed, to get it in the right units for the moles, that's just by dividing by 1,000. And then we know that 1 mole of hydrogen is 24 decimeters cubed per mole. So how do we convert our rate into a rate in moles per second? So if we divide the rate in decimeters cubed by how many decimeters cubed are in a mole, that's 0.012 over 24. How do you do this without a calculator? Well, 12 over 24 would be 0.5. So 0.012 over 24 is 0.5 divided by 1,000, which is 0.0005. Which is our rate in moles per second. So we have the rate with respect to hydrogen in moles per second. How do we get the same thing for magnesium? Well, if we look at the equation, we have 1 mole of magnesium forming 1 mole of hydrogen. So what does this mean for the rate? It's going to be the same, just in the other direction. So now we have the rate for the right species in moles per second, but we need it in grams per second. So what's the last thing we need to do? So if we change from moles to grams by mass is number of moles times relative atomic mass, which we're given here. Putting the numbers in just gives the rate in grams per second is 0.0005 moles per second times 24. So how do we do this without a calculator? Well, what would 0.5 times 24 be? That's 12. And if we divide that by 1,000, what do we get? That's 0.012 grams per second, which corresponds to answer A on the question paper.